of AI systems which we want to develop those kind of intelligence, right? We see that there needs to be two kinds of intelligence in there. One we call as inductive intelligence, another is called as deductive intelligence. In Watson case, I find it a lot of textbooks. It got a lot of general knowledge. It can answer any fact in the world, right? Which is related to general knowledge. But now I give a God question. What is the capital of the second largest populous country of the world? Is that given as a fact? It won't. Only raw facts are given, right? But I will still ask Watson to be able to perform a result of such a query. It is expected. How do you work on it? You take two different facts, combine them to generate a composite fact. That is what is known as deductive reasoning, which we have been very good when we were all doing class 9, 10, 11, 12, Euclidean geometry. All of us have done some kind of proof, right? There are these axioms. Prove that alternate angles of the parallel lines are equal. Or proof for mathematical induction. If you remember that, up to n, proof for n plus 1. Base 1 it's true. What is that? That's basically an example where using logic based on existing set of facts, you can derive new facts. And that is a basic requirement for any AI program to be able to perform, because you cannot feed all the data into the system. So based on some facts and some rules, it should be able to derive new facts. And that is one aspect of intelligence which is very commonly now required as part of every generic AI system out there. The other one, which is the other side, where suppose I don't have patterns or rules to describe, but I have tons of facts, tons of data. Then can you derive generic pattern or a rule from the original data? And that is what is machine learning. What is machine learning? Machine learning is the art of extracting patterns from raw data without explicitly programming. And that, my friends, is what deep learning is able to do as a subset of machine learning when fed with tons of unstructured data. Machine learning, conventional machine learning was very good at structured data. You give a lot of rows of Excel, 10 variables, 20 variables, 100 variables, doesn't matter. It's very good. You will extract patterns with a decision tree or from an equation or some kind of support vector machine. But those are very good for structured data. But the moment you bring unstructured data into the picture, these methods are not so scalable. They are not so easily applicable for the three kinds of unstructured data. What are the three? Speech, text, and image. Keep that in mind. That is the reason why deep learning is required today, to offset that limitation of structured data and limitation of conventional machine learning. So that's what, if you see here, machine learning needs to deal with all kinds of data. You cannot deal only with structured data. You need to deal with speech, you need to deal with language, you need to deal with image, you need to deal with video. And all of that, today we are able to confidently say that I can create a system like Watson, or I can create a system like Devil's Card, or I can detect a system for detecting movements of constellations, or I can detect a system for understanding how a malignant tumor differs from a benign tumor. All of that is possible because we have interesting inductive machine learning algorithms based on deep learning which can work on these kinds of data.